All right, so folks, we're going to start off by reviewing what we did back in chapter 2. So I've got an equation up here. This needs to be down on your sheet. I see many of you have written it down already. And then we're going to fill out this table and make a graph for it as well. I want to remind you of a couple things. When you're looking at this equation, one of these two numbers is the starting value. Which one is the starting value? The 2 or the 1? The 1 is the starting value. Now the starting value goes here in the table. And the other number in our equation is what? What does that 2 represent? The slope, or sometimes we call it the change. That change is going to tell me how I change to go to the next y value. So could you guys take a moment and fill out that table and then graph those points and connect them together, put some arrowheads on it because it would go in both directions forever and ever. While you're doing that, I'm going to pass out something that we'll be using in just a sec. One for each of you. The 2 here tells us that this is going to go up by 2. What did you have in this spot right here? You put 1 in there. Well, what's 1 going to turn into if you go up by 2? Well, yes. We have blinds on order, but they're back ordered right now. So we just kind of got to deal with it. The sun's moving pretty quick in the sky. So if the sun's in your eyes right now, just be patient, and probably 5 or 10 minutes, it'll be off of you. I think if you each, yeah, you each have one. Get one. Did I miss anybody for the handout? Everybody have one of these? Did I? Oh, he's got 2. Yeah, we're good. Okay, so we said starting value was 1, right? And then we're going up by 2 each time. Did you have 1, 3, 5, 7 in your table? Yes. And you graphed those points, and we had said that this 1 was also going to be our y-intercept. So did you have your line crossing the y-axis at 1? And our slope was 2 over 1, up 2 over 1, up 2 over 1. It would look something like that. And if we connected that with a straight line, we're going to see something like this. So we spent a lot of time in semester 1 talking about these types of functions. These are called linear functions. I'd like you to write that word down in your notes, linear. They're linear functions because, why do you suppose they call them linear functions? Because they're lines, right? And by the way, this is a common misconception in Algebra 1. In math, we don't have to worry about saying a straight line, because in math, all lines are straight. Okay, by definition, a line is straight. There are no curved lines in math. A curved line, what you would call a curved line in art, we would just call a curve. Okay, so this is a line, and all linear functions are always going to be lines. So second semester, we get to branch out a little bit and talk about some other type of functions. So chapter 5 is all about a different type of functions called exponential functions. And we're going to get into that today. And the reason I had you do this is because I want you to remember this table and this graph, because we're going to graph some exponential functions. And I want us to do a little bit of compare and contrast. So keep this in the back of your mind, but let's switch over to our textbooks. Could I get you guys to open up? And if you're sharing a book, make sure both people can see it. Could you please open up your books to page 195? And we've got 2 paragraphs that we're going to be reading here for problem 5.1. Go ahead and take a moment right now and just read silently to yourself these 2 paragraphs in 5.1. So it starts with in the book, and ends with two babies. Make sure both people can see it, and then we're going to come back and read it again aloud. If you don't have a book, go ahead and grab one from the shelf back in the back of the room, please. Okay, so I like to read this aloud, and the way I've done this in my class, it's worked pretty well, is I'll ask for a volunteer to read just one sentence. When that person's done reading, then they get to pick who's going to read the next sentence. So is anybody willing to be brave and volunteer just to read this first sentence that begins with "in the book"? Thank you so much. Awesome. Could you pick someone to read this short little one that comes after it? Thank you. Please, can you start off what if? Just that one sentence. Are you willing? There are how many? There's 6 words in there. Please, please, please. Blaze, can you pick someone else to read it then, please? Thank you very much. Can you pick somebody to read the next sentence, please? And pick someone for our last sentence. Who was it? Just the last sentence. It starts with "also suppose." You got this. That weird word in the middle is "thereafter." Awesome. Thank you guys for doing that. I appreciate it. Okay, so we all got an idea of the situation. First of all, who's read that book of Mice and Men? Do they still read that? Yeah. Okay. Okay. Well, we got a couple characters, and they've got a bunny farm going on, and we're gonna kind of do what we did a second ago, but with this situation. So this is where we're gonna switch over to that sheet that I passed out to you, and we're gonna work through this together as a whole class team. And I'll kind of lead you through the first part of the problem, and then I'm going to have you do something very similar on your own in a minute. Okay, so really important that you pay attention, close attention now, get your questions answered, because in a minute you're going to be doing something very similar on your own. Okay, so what we're going to do is we're going to represent this situation 3 ways. We're going to make a table, we're going to make a graph, but first I'm going to make a diagram, and I'm going to use this big empty space at the bottom of my page to do that. So I want you guys to help me through this. We're going to kind of represent this situation with a little picture. And well, let's go ahead and just get started. So at the beginning, how many rabbits did they have again at the beginning? 2 bunnies at the beginning. So I'm going to draw myself 2 little bunnies here. 1 bunny, 2 bunnies. See their little ears there? You can just draw circles or X's if you want. And that's how many they have at the beginning. So I'm going to put a little dashed bubble around this to remind myself that this is at the beginning, the start. Now, as we go through time, every month this is going to change, right? Go back and find the sentence in the reading that told us how it's going to change, and see if you can figure out for me, how many bunnies are we going to have 1 month later? How many total bunnies are we going to have? 4. We're going to have 2, so just the same 2 bunnies here. Do these bunnies have babies? How many? 2. Each bunny has 2 bunnies. Okay, so each pair has 2 babies. So there's a pair here. They're going to have 2 babies. So we're adding 2 more bunnies. Okay, So let me draw my two babies here. And those would be, so it seems like at the end of 1 month, because the original two bunnies are still there. Seems like we've got 4 bunnies. Ooh, I love that you're already starting to think about patterns. That's going to be super important. So let's keep going with this. So what's going to happen at the end of the second month? So it says each pair, how many pairs do I have here? I got 2 pairs, right? Each pair is going to have 2 more bunnies. So this pair is going to have 2 bunnies. And then this pair is going to have 2 babies also. So I'll put a little bubble around all of those because all the original ones keep surviving. And I'll label that bubble 2 months. So what do you guys, how are we feeling about this right now? Do we want to go ahead and make a drawing for the next one, or are we starting to see a pattern? I know that some of us are starting to see patterns. Why don't we fill in our table? Here's a handout for you. Why don't we fill out in our table for this situation that we have so far? We said at the 0 months, this would be our start. We had 2 bunnies. That was our original down here, right? So go ahead and put a 2 there. And after 1 month, how many did we have again? After 1 month, we had 4 bunnies. Handouts right here. After 2 months, we had how many? Are we seeing a pattern in these Y values that we might be able to just kind of carry out the pattern numerically? Or do you want to draw the next month? What's the pattern you're seeing? Can you come grab a handout? Thank you. You're thinking we're multiplying by 2 each time? So times 2 times 2. So we think we're going to do that again? Well, I'm just going to go ahead and draw one more just to make sure, because I don't hear a lot of people being super confident. I know that one of you is very confident. I know that 2 of you are very confident. But we've got 4 pairs here. Each of those pairs is going to have 2 more bunnies, right? There's 1 pair, 2 pairs, 3 pairs, 4 pairs. If I add those up, that is 16, isn't it? That is 16 bunnies altogether. So it is. I think we figured out the pattern. So help me fill out the rest of this table. 16 times 2 is 32. 32 times 2 is 64. All right, would you guys please go ahead and graph those points? And I see many of you grabbed rulers today, but I do not want you actually using the rulers to connect those points today. So those rulers will be great as a bookmark. Now let's be careful when we graph here, because notice the y-axis is not going 1, 2, 3, 4, 5, is it? What's it doing on the y-axis? 10, 20, 30, 40, 50. So when I try to make 2 on here, 2 is going to be like, it's going to be just a little teeny bit above 0. It's definitely not more than this first tick, because that first tick is at 10. So here's 0, 2. And we've got 1, 4. You guys filling these in? 2, 8. 8 is almost up to that first tick mark, a little bit shy of it. 3, and then I need to go up 16, so tick mark 10, and then about a little more than halfway between 10 and 20. Or was 32, so I need to count up 10, 20, 30, and a tiny little bit more. 32 would look like that. 5 is 64. 10, 20, 30, 40, 50, 64. And I am going to connect my points here, but I'm not using a ruler because those don't look like they're going to fall into a straight line, do they? Okay, so we're going to see a lot of graphs in this unit that are going to look like this one. And I just want to do a quick compare and contrast to what we did at the beginning of class. What's different about our tables this time around? How are these tables different from this table? Awesome, awesome. I heard it in stereo. Great answer for both of you. Do you guys hear those responses? In one, we're adding to. So for a linear, we're adding the same thing each time. But this one, we're multiplying each time. I want you to look at the graphs. What's different about the graphs? One's curved, one's straight. Okay. So we're going to familiarize ourselves with these new types of functions. These are called exponential functions. We'll get into all the nitty-gritty details, but today we're doing just trying to kind of wrap our heads around some problems and how they work. So you can go ahead and flip this sheet over onto the back. You got a blank copy right here. What's going to happen now, and I warned you about this a moment ago, we just went through one situation together. You're going to do one on your own. So in your book now, please turn to the next page. Down at the bottom of that page, problem number 3. In part A, can you guys find where it says case 2, case 3, case 4? You see what I'm talking about? I'm going to assign your table partner, you and your table partner, one of these cases. They're all very similar to the Lenny and George case that we already did. That was case 1, except they're a little bit different. Case 2, we're going to start with 10 rabbits instead of starting with 2, but we're still keeping 2 babies per month, the same. Case 2, you're going to start with 2, same as before, but you're going to get more babies per month. And case 3, you'll start with 2, and you'll get even more babies per month. Your job is to work with your partner for both of you to fill out the table and the graph. Now, you don't have to do a diagram, but I highly recommend it. Okay. When we get finished with this, we'll come back together and chat a little bit more. And then my goal is to give you a good chunk of time to start on the homework this morning. So I'm going to come around and tell you which case you're going to be. I'm going to have to shift some people around as well. So be patient with me here just a second. All right, let me get your attention. I just want to show you graphs that some of your classmates, graphs and tables that some of your classmates have made for the other cases. So you did one of the cases, but there were 3 here. So this was case 2. For those who did case 2, did you come up with these same y values for case 2? Yeah. Okay, good. And we said in this case we're starting out with 10 bunnies. And remind me, case 2 people, how many babies were each pair having for case 2? It was 2. So it's kind of interesting because they're having 2 bunnies per case and they're multiplying by 2, right? And that was kind of what we saw before. Let me show you case 3. Now, case 2 people, you'll want to pay attention to this because this is going to kind of seem strange to you. In case 3, we also started with 2 bunnies, but how many babies were we having each time for case 3? How many were we having each time? We're having 4 babies each time. So you might think that this would multiply by 4. Did anybody think that originally? But if you actually work it out, there would be 6, and then there would be 18 and 54. What are we multiplying by each time here? We're multiplying by 3 instead of by 4, which seems kind of strange. We're adding 4 more bunnies per pair, but we end up actually multiplying by 3 in this. And then this is case 4. Now they were only starting out with 2 bunnies, but this time every pair was having how many babies? 6 babies. And look what our multiplier ended up being this time. What are we multiplying by each time here? We're multiplying by 4 each time. So it seems a little strange, and I know that that's kind of weird to wrap your head around, but don't worry about that so much as the main thing I want you to take away from this is These are all exponential graphs, and what makes them exponential graphs is that pattern that each of you was able to find in your group. You all figured out that there was some number that we were just multiplying our y values by, and that was getting our next one. And that's the key, is figuring out that multiplier. I also want you to look at the graphs. Look how the graphs are different. So this was case 2 versus case 3. Now, case 3 is a little bit steeper than case 2, but look how steep case 4 is. If you didn't do case 4, they actually weren't even able to graph the last 2 points because the last 2 numbers were so big that they ended up going off of the edge of the graph. All right, so I want to take you through one more quick thing. If you guys could go back to the notes that we started at the beginning. Just want to take some really quick notes on what an exponential function is. So let's just write down that word, exponential function. And the big important thing that we got today was that an exponential function has a pattern where we do what to the y numbers? We multiply by the same number each time. We keep multiplying by the same number. So for example, and I'm going to just make a small table here just to give an example of this, x, y, 0, 1, 2, 3. What do you guys want our starting value to be? Let's make up something new. 3, we never started with 3. What should we multiply by each time? We want to go by times 3 also? All right, we'll do times 3. So 3 times 3 is 9. And then if I wanted to get my next one, I would just keep doing times 3. 9 times 3 is 27. Anybody know what 27 times 3 is? 81. Good. And it would just keep going like that. Dot, dot, dot. It would keep going like that forever and ever and ever. Keep getting bigger and bigger and bigger. Anybody know why they call these exponential functions? They grow exponentially. And where did that word exponentially come from? Let's think about, what does an exponent mean? Where does an exponent make our life easier in math? Never? It never makes your life easier? Oh, yes, it absolutely does. What if I asked you to multiply a bunch of 3s together? What if I asked you to multiply 3 by itself 57 times? Are you going to want to write out 3 times 3 times 3 times 57 times? No, you don't. No, you don't. No, you don't. And you wouldn't, because we have a shortcut for it. What would you do instead of writing out 57 3s? You'd write 3 to the power of 57. What's another word for this power? Exponent, an exponent. So these are exponential functions because just like an exponent, you're multiplying, right? This 57 means we're going to multiply this 3 over and over and over again 57 times. Isn't that what we're doing over here? We're multiplying by 3 over and over and over again. So that's why they call these exponential functions. Exponential functions, I'll be honest with you, this is probably the most important thing that you're going to learn in Algebra 1 in terms of your actual life after high school. Because exponential functions is the math behind money, mortgages, investment accounts. Those things all work on the math that we're going to be learning about. Okay, you're going to learn about how exponential functions grow a little bit at the beginning and grow much faster at the end. And we're going to tie that into some strategies that, if you actually listen to some advice I'm going to give you, is going to make you a lot of money someday. I'll warn you, I got the same advice when I was your age and I did not listen to it. And I don't have a lot of money right now. I got plenty of money, but I could have millions if I just paid attention to my math teacher in high school. So that's all we're going to get into for today, though. Okay, this is just kind of a basic introduction, dipping our toe into it. I need some help passing out these packets. Who can give me a hand with that? I really appreciate it. Yeah. Oh, thank you for sharing that. The part D asked how many you're going to have after 12 months, right? After 12 months, and thank you for, can you read that number to me again? This is how many bunnies, if we kept going for, which case was it? For case 4. That many bunnies. Now imagine if those bunnies were dollars. That would be kind of nice, right? So I hope they've got a lot of feed at that bunny farm, because that's going to be a lot of money to feed. Who's going to help me pass out some papers? Please, please, please. Can I get a couple people? Thank you. Come on up. You get this side over here. Parker, you get this side closer to you. Thank you very much. Appreciate it. What's that? New packets, yeah. Hey, so, all right, guys, I need your attention just for 2 more minutes, and then you're going to have lots of time to start on your homework. And at that time, you can work with someone else. And as long as you're being productive, you'll be able to chat with one another and get some stuff done at the same time. Look up here for just a minute, though. Thank you, guys. I appreciate your help. So we're back to packets. I'm going to be stamping your assignments instead of having you turn them in. Let me just show you how this is going to work. First of all, this first assignment is going to be due on Monday, which I believe is the 20th. Can anybody confirm that? 3/20. This is the back of the packet, back page of the packet. Sorry, back page of the packets where we're going to stamp homework. All of these questions are from chapter 5. It's a bigger assignment, but I'm giving you a big chunk of time for it today. Just so you know, if you bring it on into me and it's finished, and for me, finished means that you've tried every problem. Okay, that means that you wrote down the problem and I can see that you did some work on it. It is not okay to just write down the problem and put a question mark next to it. That's not work. I need to see that you've actually tried something. You may not finish it. You may have some questions. That's fine, but show me that you've tried everything. If you do that, I'll stamp it. It'll be worth 10 points. I'll stamp it in that category and it'll be worth 10 points. Now, if you bring it to me instead of on next Monday, you bring it to me like next Wednesday or next Friday, you'll get a stamp here and it'll be worth 7 points. If you bring it to me Monday and it's halfway done, I'll give you a 3. But if you bring it to me Monday halfway done and I stamp you here, but then you finish it, say Wednesday, I'll upgrade you to a 7. Okay. All right. And then this column's for if you're absent. Just let me know if you're absent and I'll write the date in this column to give me a reminder that I need to give you full credit next class. So that's how the stamp sheet's going to work. Don't worry too much about what's inside the packet for right now. We'll get into that later on. I am going to tell you this, though. I'm about to pass back some stuff, including, oh no, I can't today. I'm going to pass back your chapter 4 packets next Monday. I do not want you throwing those away, okay? If you want to throw away your homework assignments from chapter 4, that's your call. You should not throw away your packet. Personally, I would also not throw away your practice test or the chapter review. I would hang on to all of those things so that you can use them to study for our next test, which is also going to have all that stuff on it, and also our final exam in June. All right, questions for the greater good? Will you be able to use your notes on the final? I'll be able to answer that question closer we get to it. Well, we have to discuss as a department. In the past, we have allowed students to use a page, like to create 1 page of notes. Yeah. Other questions for the greater good? Or is this an individual question? I'll come around to you in a second. Any questions for the greater good? All right, you're free to move if you want to work with somebody else or just sit in another spot that's not so sunny. I do need you guys working. Those phones need to stay away for the period. Let's be working on this assignment. It'd be awesome to walk out of here and not have any homework this weekend, right? Get after it. Let me know if you got questions. I'll be with you in just a sec. Okay, stop this thing.